All right. Hello, everyone, and welcome to the first kind of real video of material that you don't already know. I just wanted to put the list of what we'll be covering in this video. We're going to cover phase changes and how to do heat calculations that go along with phase changes. And then we will cover calorimetry, which is the method to measure energy content in substances. But I hope all of your at-home learning is going well. I figured I would first give you a little update as to how my at-home teaching has gone. So yesterday, I got up. It was, I think, like 6:45, so it's still dark out, and my wife Casey's already up. So I walk into my bathroom, and it's still dark. And so how my bathroom is it's a long hallway with the shower at the end, and there's a glass door on that shower. And then if you turn right, it goes into the water closet. So I was going back to the water closet in the dark, and you know how when you wake up right first thing in the morning, you're kind of just like out of it. So I'm like walking, and apparently the shower door was left open, so it was open out into the bathroom. So at about 6:45 in the morning, I'm walking blindly back into the shower, and I run right into the shower door head first and got a knot right on my head. So that was the start of my morning. Then later in the afternoon, we got a delivery for this little piece of furniture. It's like a little shelving unit. And so I'm opening the box, and it's just a cardboard box. And you know, like when you get the one flap open, and then you run your fingers underneath the flap to kind of loosen it up and then pull it up. So I was doing that. And when I ran my finger across underneath, there was a staple hanging down. And so I ran my finger right across it, and the staple went right through my finger. So it was a very wonderful start to my at-home work. I hope your days have gone a little smoother, and you're not getting too crazy bored, and you're keeping your distance from everybody as well. All right, so phase changes is what we will cover first. So let's start learning phase changes from the corner of my dining room here. Okay, so phase changes, these are going to be a little different from what we already know. Okay, so think about what we already know dealing with increasing the temperature of materials or decreasing the temperature of materials. We already know that the energy required to either heat up a substance or cool down a substance is given by the equation Q equals M times C times delta T. Okay, we've been using that now for a while. The thing is, this only applies to substances that are staying within the same state. Okay, so if you want to heat up water, liquid water, from 4 degrees Celsius through 95 degrees Celsius, it's going to stay liquid during that entire temperature range, right? So you can use this equation to calculate the heat required in order to do that temperature increase. But it doesn't work when you're going through actual phase changes, okay? So think about what happens when you're increasing the temperature of a substance that remains in the same phase. So let's just think about liquid water, okay? If you're increasing the temperature of the liquid water, what are you actually doing to the molecules of water? Good. All you're doing is giving them energy to speed them up, right? They're just moving faster the higher the temperature is, Okay, now that's the same for in solid state or gaseous state. In a solid, they're closely packed, but they're sitting there vibrating. The molecules are still sitting there and vibrating. When you increase the temperature of a solid, those particles, which are vibrating, just vibrate a little faster, and then a little faster, and then a little faster, okay? But this is different fundamentally from a phase change, because what is actually going on in a phase change? Well, you have, remember, you have, let's say for water, you have these water molecules packed closely together. And if they're in a liquid, they're freely moving, but they're still closely packed. And then there is this interaction between different water molecules, right? We have this one water molecule here and this other water molecule there, and they are interacting with each other through, good, intermolecular forces, right? This little dotted line I drew here represents what type of intermolecular force? Good, hydrogen bonding. Okay, so there's hydrogen bonding going on. That's an attraction between the two water molecules. And so when you go through a phase change, what you're actually doing is either making or breaking those intermolecular forces. If you're boiling the liquid water to go from a liquid to a gas, you're going to break these intermolecular forces altogether so that there's no interaction between the molecules. This is, again, fundamentally different from just heating up a substance that stays in the same state. All you're doing then is just increasing the temperature and making the molecules move around faster. Here, what we're doing for phase changes is we're actually making or breaking those intermolecular forces. Okay, so first, let's make a list of all of our phase changes, just in case I'm using some terms that we don't have in our vocabulary already. So I'm sure you can rattle off a bunch, but the ones that we need to know are, let's just start with, let's go melting. Actually, let's keep them separate. So we have melting, we have freezing, we have vaporization. Okay, a lot of you might think of evaporation or boiling, but the general term is actually vaporization, with boiling and evaporation being specific types of vaporization. We have condensation. And then we have the two kind of strange ones that are less used. So we have sublimation and deposition. Okay. Now, if you've heard of those before, just think about which ones would require energy or require the input of heat, and which ones would release energy or get rid of the substance's energy. And so hopefully you can kind of think about these where melting, vaporization, and sublimation. Sublimation is going from a solid straight to a gas. Deposition is the opposite, going from a gas back to a solid, just in case you didn't know those. But the ones that I have starred are all the ones that require energy. Okay, if it requires energy, if this requires heat, then what would the sign of your heat be if it's required? Good. It would be a positive Q. Okay, that's requiring heat. So that would be all of the starred ones. And then the ones that aren't starred are all of the ones that would have negative Qs, where you would release heat. Okay? Now, again, for all of these phase changes, you are never changing the substance, right? The substance always stays the same. Solid water, when it melts, is still water as a liquid. It's not changing the substance. All you're doing is making or breaking intermolecular forces. The ones that are starred would require you to break intermolecular forces. The ones that are not starred are the ones that would end up making intermolecular forces. Okay? So, let's talk about how we do calculations for phase changes. Let me take a break quick.